Hello. In this video, we're going to be talking about a bunch of the electromagnetic radiation spectrum. So first, we're going to talk about some of the discoveries for that spectrum. So in a timeline, we started off with figuring out how visible light worked. Okay, this was Sir Isaac Newton, and it happened in 1666. A couple hundred years later, we had Sir William Herschel figured out how infrared worked. Then UV radiation by Johann Wilhelm in 1801. Then we had Heinrich Hertz that discovered radio waves and also microwaves 7 years later. And in 1895, Wilhelm Röntgen discovered X-rays. And lastly, we figured out gamma rays in about 1900. Paul Villard was the very first scientist to see this happen. So all of the different spectrum were discovered at different times. So now we have to understand how some of the different waves of radiation can travel through the Earth's atmosphere. So some of the Earth's atmosphere will actually absorb some of the EMR spectrum. So like some types of UV radiation, okay, some visible light and some infrared radiation actually gets absorbed. And these get absorbed by different gases like water vapor, carbon dioxide, and the ozone layer will actually absorb these types of radiation. So in this picture, it kind of shows different wavelengths of light. So we have a part of the UV in the visible. We have some stuff in infrared. We have even microwaves over here. So depending on the different wavelength and depending on the different gas, so we have different gases also listed that are absorbing these different layers in Earth's atmosphere. Electromagnetic radiation has been really helpful in many different situations. So we're going to go through a bunch of different situations where electromagnetic radiation is used. So for example, in the medical field, we have kind of briefly talked about some of these things. So for diagnostic procedures, there's many different things that we can use, such as CT scans. CT scans use X-ray radiation in order to create an image. Ultrasound doesn't technically use EMR because it uses sound waves. But I thought I'd include it because ultrasounds are super common and they're kind of a similar technology, but instead of using waves of electromagnetic radiation, they're using sound waves instead, which honestly blows my mind that they can create an image out of waves of sound. But that's a whole different story to talk about later. Obviously, X-rays themselves, the machine that creates X-rays, can also be used for mammograms, specifically looking for breast cancer. MRI uses both radio waves and also uses magnets to kind of move them around. PET scans are really interesting. They actually put a radioactive substance inside of the person, which will actually break down in the person and give off gamma rays, and that's what's creating the image. So it's actually doing like radioactive decay inside of the body to see what's going on. And then something like an angiogram where they put radioactive dye into the heart and they can see the vessels in the heart. Can be used. X-rays are used to actually see the image. They also have things like pulsed electromagnetic field stimulation, which has been used in the medical field to help patients with the healing process. So they can help with like bone repair and nerve stimulation and tissue regeneration, which I thought was super interesting. I'd never heard of that before I did some research on it. Also different types of oncology radiation, which is oncology is like cancer treatment or cancer research. So brachytherapy is putting like little tiny pieces of metal that include radioactive material right next to the tumor. So then the radioactive material will be released from this little tiny insert, and then they take it out later, and that will kind of be like similar to using a machine to send radiation through the body into the tumor, but obviously like a little bit easier to send it right directly to the tumor, and it will hopefully not break down healthy cells as much. There's also linear accelerators, which use X-ray radiation, and they basically like magnify the radiation so that it's a little bit more intense, so that it can penetrate the skin a little bit more. And then gamma stereostatic radiosurgery, which is used to send really high dosages to specific areas if you have cancer in the head or the neck. Obviously, we want to protect the brain because it's super important. So we want to be really specific on where we're sending the radiation, and that's why we use it specifically in that area. So this would be the type of radiation that my mom received when she had cancer treatments. We also use electromagnetic radiation, usually radio waves, communication forms. So television, to be able to connect to like cable, uses radio waves. Radio, obviously, in your vehicle, or if you're listening to it on an external radio device. Hey, your cell phones. using Bluetooth and Wi-Fi and GPS and also like airdrop technology all uses radio waves in order to communicate with each other. So I would say radio waves are pretty important in our day-to-day life. Industrial, so like different companies would use different electromagnetic radiation in order to solve certain problems and help with certain issues. So for example, there's things like gauging devices that are used to maybe measure like thicknesses of certain substances or to see the flow rate of liquids or to measure certain things. Usually these contain radioactive materials that release gamma rays. And some examples of gauging devices or like similar to gauging devices would be an X-ray fluorescence analyzer, which is used to actually analyze the makeup of an item specifically, like what's inside something. And then also gas chromatograph, which is used to figure out like how pure a substance is or like if it has the correct mixtures of substances in it. We also use it in the oil and gas industry, something called well logging, which is basically like a long skinny tube that you would stick into a drilled well, and it can help you figure out the minerals, the rocks, if there's gas or oil and other substances. My husband, who works in the oil and gas industry as a geologist, he has actually used well logging before and was kind of explaining it to me yesterday. Literally just a long skinny tube, he said that, but it is filled with radiation in the tube, so when it releases gamma rays, it can kind of, depending on how the material reacts, it will then tell you what the material is. There's also industrial radiography, which is also known as non-destructive testing. So if they're looking at pipes, for example, so like pipes underneath the ground, instead of having to dig them up and try to check them, they can use this technique to basically send a machine, an X-ray machine, or they can use radioactive material and basically get images to see if there's any defects in the pipe, like cracks or holes or anything. Instead of having to replace ones that are still good, they can use this machine to kind of see if it is going to have leaks in it. We also use it a lot for sterilization processes. So for example, hospitals or sometimes when they're creating food for consumers to eat, even post offices will actually sterilize some things. I found it interesting that post offices will use it sometimes to basically, if there was like someone was sending something like a bomb in the mail, they could actually like sterilize the material and cause it to no longer be like radioactive or cause it to explode, which I thought was super interesting. Hospitals and food preparation would be like destroying the bacteria or viruses on surfaces or inside the food, so that obviously it's not getting people sick. And then the last one, I thought this was super interesting as well. Sometimes they might not be able to actually connect somewhere to a power line because it's in the middle of nowhere. So for example, like a spacecraft or a satellite or lights on the ocean buoys obviously wouldn't be able to connect to actual power line. So they sometimes use actual radiation sources to make electricity or thermal power in order to actually power these things. Okay, and also like weather stations also will use this technology. So a lot of different things that people have figured out how to use radioactive technology in order to make things more efficient and be able to finish these processes. The last one that I was asked to talk about is environmental problems. This one was a little bit harder for me to figure out stuff. I had to do a lot of research to figure out some stuff, but some of them are a little bit random. So for example, they have figured out to use radiation from UV rays, and they can actually like break down plastic. Since plastic is not biodegradable, it can like persist in the environment for like thousands of years. So they can use UV radiation that will help kind of degrade it a little bit, which is pretty interesting. Also, the fact that they're sterilizing food so that they're killing microorganisms. This would obviously be affecting the environment for that microorganism, and it's helping humans because we're not getting sick from it. So technically kind of environmental. Also, I wanted to mention, of course, plants perform photosynthesis, which is using visible light, and they're using the energy from the visible light in order to make not only like sugar that we eat, but also the oxygen that we breathe. So arguably photosynthesis, which is using visible light, which is an EMR, is really like the most important thing. The reason that we're allowed to live on Earth is because of this process. So I would say it's pretty environmentally tied to. Also, different scientists, I just kind of wrote, like, for example, weather, water, or climate scientists obviously have to use different technologies using EMR in order to actually collect data. Things like conservation biologists that are like looking at populations of animals will be using tracking devices. And then also all scientists that are would use communication devices, so like cell phones and computers and like all of those things, internet, Wi-Fi, GPS tracking, like all of those things would be able to be used by scientists in order to get information about the environment, in order to actually then share that information with the world. So I thought that was also important to mention. So how we used EMR to actually help us understand the world around us, first talking about the universe. So we will talk a little bit more about space in the coming days, but we use telescopes to study the universe. So different components in the universe, like black holes or different celestial bodies. So telescopes form enlarged images of those distant objects in the universe. They use not only mirrors, but also some lenses to focus those waves of EMR spectrum, okay, which includes visible light, but we could also have other telescopes that are using other types of EMR so that we can actually get information about those celestial objects and learn more about them. So if we're studying the electromagnetic waves given off by the objects, such as like galaxies or black holes or even stars, the scientists or astronomers can figure out different things about those celestial objects and learn more about the universe and understand it better. So telescopes usually are designed for a specific type of EMR. So like maybe it's collecting radio waves or infrared or visual light. So normally when we're looking at objects in space, they won't just use one type of telescope. They will use several telescopes to get more information about that certain object. So for example, this is a bunch of pictures from different types of telescopes of the Milky Way, which is the galaxy that we live in. So radio waves, infrared, visible light, X-rays, and gamma rays. Those are all different examples of what the Milky Way actually looks like, which would be telling us different information about the Milky Way, and we can study it further. We also used EMR to help us kind of figure out how the atom worked. So in Science 10, you might remember learning about the different kind of models of the atom, okay, the plum pudding model, the Bohr model, like all of these different types of models of the atom. Okay, now this is kind of the current model that we kind of use, but scientists didn't really understand the difference between basically like electromagnetic radiation and the actual atom itself. So they were like comparing it / like thinking it's basically the same thing. So as they studied this, they kind of had to like differentiate between like electrons and other subatomic particles like protons and neutrons, and actually like how electromagnetic radiation is working. So for example, specifically like Thomson, the one that had the plum pudding model right here, when he was doing his cathode ray experiment, he was like trying to prove that EMR and this experiment was going to do the same thing. So he noticed a couple of things. So for example, electrons, which he called cathode ray tubes, electrons were traveling in straight lines just like EMR would, and also had similar chemical reactions that were producing light, okay, like visible light in the EMR spectrum. So he also observed some differences. So first of all, electromagnetic radiation would be influenced by electric and magnetic fields because it is an electric and magnetic field itself. If you have other electric and magnetic fields interfering with it, it would then change the course of the EMR, but electrons didn't seem to do the same thing. So because he noticed this, he decided after his experiment that they must be different things. Electrons are different than any of the EMR spectrum, like visible light or UV radiation or whatever we're looking at. So that kind of helped people understand how the atom worked, because then if we figure out what an electron is, then we could figure out eventually that it's like hanging out in orbitals, and then eventually kind of looking at more specifics to do with the different structure of atoms.